Greetings. Today we're going to talk about percent solutions and what that means when you're talking about the concentration of a medication. Up to this point in the program, we've been working with medications that have traditional types of concentrations, such as this epinephrine vial, which is 1 milligram per ml. So what exactly does that mean? When you state 1 milligram per ml, you're stating that there is 1 milligram of drug in every 1 ml of drug volume. So how much drug per volume? When we're talking about a percent solution, we're talking about the exact same concept. If we have a product that, say, is 5% drug, that is stating that there is 5 grams of something in 100 mLs of something. So let's talk about a very common medication that's on the market, dextrose 5%. So in this particular medication, this is stating that of the drug volume in this bag, 5% of it contains dextrose or drug. So it's drug per volume. When you're talking about percent solutions, there are 2 ways we can identify what a percent solution is, and that is weight to volume and volume to volume. So you may be asking, what exactly does weight to volume and volume to volume mean? Well, talking about that previous concept in our epinephrine 1 milligram per ml, we're stating that there is 1 milligram of drug, in that case the weight, per every 1 ml of product or drug volume. That's the volume. So in a dextrose 5% solution, the concept is the exact same. The question is, what unit are we talking about in regards to the drug weight? Are we talking about milligrams? Are we talking about grams? Are we talking about kilograms? Well, it just so happens that when we're working with percent solutions, there is a standard formula with which to follow. And I'm going to write that on the board right here. We also talked about earlier in the program that a percent is something out of 100. So when we're talking about percent solutions, the same concept applies. There is how much drug out of 100, and in this case, mLs. So the standard for pharmacy calculations when we're talking about percent solutions is that if a product is 5%, that means there are 5 grams, grams being the standard unit in a weight to volume, per every 100 mLs of product. When we're talking about a volume to volume product, let me get that on the board really quick right there. When we're talking about a volume to volume product, it's the exact same concept. The only difference is the unit we use for the drug may differ. So in a weight to volume, we're talking about grams per 100 ml. That's the constant, and that's what's always going to stay the same. What changes is the number in front of it, which is what we identify through the percent we're given. In a volume to volume, it's the exact same concept, and since we were talking about mLs prior, it's going to be the same idea. A dextrose 5% solution, if we're looking at volume to volume, means there is 5 mLs of drug per every 100 mLs of product. So in this case, the volume to volume is whatever number mLs per 100 ml. Now that's probably the most confusing part for many individuals, is when you look at that product, you may be like, well, how do you compare ml to ml? Well, if I were to actually pour out 100 mLs of this product, what that equation is telling me is that 5 mLs of that product is literal straight drug. So to make that product, I would have measured 5 mLs of dextrose full concentration and added that to 95 mLs of base solution to get our 100 mLs. So I'm going to digress for a moment. I know that's a little complicated, but in reality, when you're doing the pharmaceutical calculation, there's one very simple thing to remember. When you are given a percent product, such as dextrose 5%, the weight to volume, which is by far the most common percent solution calculation, is just how much drug per how much volume. Looking at the equation, all you have to do is take the number of the percent solution and rewrite that number and then make that grams per 100 ml. Once again, let me stress, it's always the same units. It's always gram and it's always ml when you're talking about a weight to volume product. So let's talk about another percent solution, such as sodium chloride 0.9%. In this particular product, the same concept applies. This is stating that there 0.9% of this bag contains raw or full concentration sodium chloride. So I'm going to write that on the board. Sodium chloride, I'm going to draw a line here so we see the separation. Sodium chloride, 0.9%. So using what we did above, I want to know what the concentration would be listed as a weight to volume product and a volume to volume product. So looking at both of those strengths, if we're dealing with a weight to volume concentration, we know that it's whatever number that is, gram per 100 ml. That's the first thing you should do, is look at a product and say, okay, if it's the weight to volume, what are the units I'm working with? It's always gram to 100 ml. And what goes in front of the gram is whatever the concentration or percent strength of that particular drug is. So the weight to volume calculation for a sodium chloride 0.9% is 0.9 grams per every 100 mLs. Looking at the volume to volume strength, if we were looking for that particular calculation, the exact same concept applies. It's however many mLs per 100 mLs. And when I say whatever many, what I mean by that blank space is, once again, that's the number of the percent solution we're working with. So in this case, that would be 0.9 mLs per 100 mLs. So the only real trick in when you are calculating percent solutions is to remember what number you're putting in front of the units and what those units are. So if we have a drug that's dextrose 5%, that means that there are 5 grams per 100 ml. Pretty simple, right? So let's put that into a problem. All right. So in this first problem, what I'm going to do is tell you have a particular percent solution. So, kind of like I just mentioned a minute ago, you have a 5% dextrose solution. In the question, I want to know how many grams of dextrose is in 30 mLs of this solution. So how many, being our X value, of grams of dextrose is in 30 mLs of this solution? Well, when we've been doing traditional dosage calculations, I tell you to typically start with the fractional concentration. So if it states you have a product that is 10 milligram per 2 ml, that is half your equation. And then the other half of the equation is the known variable and the unknown variable. In this case, the known variable being 30 mLs and the unknown variable being X grams. Well, doing these problems is the exact same concept. The only difference is they don't give you the concentration of the product as a, for example, 10 milligram per ml. They give you the concentration of the product you have as a percent solution. So this goes back to why we are talking about how to define what a percent solution tells you in regards to concentration. So in this particular problem, once again, you have a 5% dextrose solution. As soon as you see that, bells should be going off in your ear going ding, ding, ding. I need to do something with that dextrose 5%. And you'll know, even though it doesn't state if you're doing weight to volume or volume to volume, you'll see that the question is asking for how many grams. So as soon as they state that, they're saying that the drug amount is in a weight-based metric unit versus a volume-based, because again, we're talking about grams. So as soon as I see a problem like this, and when I typically do dosage calculations, I want to write down what's the known concentration. So in this particular product, dextrose 5% solution, I can rewrite that as there are 5 grams in every 100 mLs. So It's just as if they had written a traditional concentration into the product. The only difference is they wrote it as a percent solution. So starting my problem, I would first identify what is the known concentration I'm working with. In this case, it's dextrose 5%. And I know that that means there are 5 grams of dextrose in every 100 mLs of volume. Now when you do a dosage calculation, you have half of the equation. That's what we have. Now we need to figure out what do we need. Well, looking at the problem, the question is asking how many grams of dextrose. So whenever you see the words how many, you should immediately think that's my X gram that I'm comparing this to. So setting up the equation, I know that it's X grams of dextrose, because that's what we're trying to figure out, is in 30 mLs of this solution. So I can write down here 30 mLs of solution. And just to double check my equation, this is how you would verbalize this statement. I know that if there's 5 grams in every 100 mLs, I can determine how many grams are in 30 mLs. That's the mathematical concept behind this problem. So when you solve this for X, and I'm not going to spend a lot of time going over that, because if you need to learn how to solve for X in a dosage calculation, I would refer you back to the Introduction to Dosage Calculation module. But let's just say for sake you remember how to solve for X grams. We're going to multiply across, and then we're going to divide by the remaining value. So the answer to this problem, when you state X grams per dextrose, the answer to this problem, let's just think this through. Actually, you know what? I'm going to grab out a calculator because I want to make sure I do this correctly. The answer to this problem is going to be 2 grams. Actually, no, it's not. This is what happens when you don't have a calculator. It's going to be 1.5 grams. Okay. You can double check my math if you'd like on your own, but I actually do know that's the answer. So, X grams of dextrose is going to be 1.5 grams being in 30 ml. So that's what happens when you do a dosage calculation. You set it up for the value of what that percent tells you. In this case, 5% dextrose tells me that there is 5 grams of dextrose in every 100 mLs of solution. We can then solve for however many grams would be in a different volume or an amount of that bag. So for example, if I were to take 30 mLs out of this bag, that means that I'm achieving a dose for the patient of 1.5 grams of dextrose. That's what that problem tells you. So let's do another problem. All right. So in another problem, I'm going to take a product such as dextrose, or let's do a wacky drug such as Mura 128. So let's say you have a product, a Mura 128 solution, but that's the name, and the concentration is 10%. You have a Mura 128 10% solution. You want to know how many mLs of this solution will yield, let's say, 5 grams of Mura 128. And Mura 128, as a reminder, is the active ingredient of this particular product. Okay. Now, looking at this problem, you may immediately freak out because you see, okay, I got a number here, I got a number here, I got a number here, I got a number here. What you need to understand is that we threw this one as a curveball because some medications may have a number in the name. So in this particular case, Mura 128 is the name of the drug. All we're really concerned with is the percent of that solution, because the percent of the solution tells you how much drug is in that product for every 100 mLs. So again, thinking about the idea of dosage calculations, how do we define this? Well, Muro 128 solution, which can also be seen as the active ingredient, right? If it's a 10% product, tells me that there are 10 grams in every 100 mLs of that solution. So I'm going to actually write active ingredient for the 10 grams, and then I'm going to write 100 mLs, and I'll write TS, just meaning total solution. So Muro 128 10% tells me that for every 100 mLs of that solution, there's 10 grams of Muro 128. So looking at this problem, we're going to see our X value in this case is how many mLs of this total solution will yield 5 grams of the active ingredient. So unlike the previous problem, our fraction on the other half of this is going to be flipped. So I know that I have 5 grams, or I'm trying to determine how much drug or volume will get me 5 grams of active ingredient. So like we've talked about in our previous dosage calculations module in practice, if grams of active ingredients on the left, on top, it has to be on top on the right. And the easy way to double check that is to just draw a line, just to kind of remember. So on the bottom should be our X value. And if you look at the problem, it is how many mLs of this total solution. All right, so once again, the most important part is figuring out the setup, right? And to figure out the setup, start with the concentration of that drug. 10% tells me 10 grams per 100 ml. Flat. Get it on the paper. Soon as you have that concentration, you then compare that to what you have or know and what you need. So in this case, I know that I'm trying to figure out 5 grams of active ingredient, and I need to figure out how many mLs will get me that. So once you solve for X for this particular problem, you'll see that the amount of solution from a 10% that we need would be 50 mLs. So 50 mLs of that product will get me 5 grams of drug. Now in this particular problem, you can actually see that pretty quickly, because if it's 10 grams per 100, and you're trying to figure out 5 grams per whatever, well 5 is half of 10, and 50 is half of 100. So that's a quick way to kind of double check that you did that problem right. But in that answer, it would be 50 mLs. So once again, the trick in all of these problems is to figure out what does that percent tell me. It means that number of either grams or mLs per 100 mLs. All right, let's do 1 or 2 more problems, and then you'll have a chance to do these for practice online. Okay. So in our next problem, we already did that. Let's say you have a 0.45% NaCl solution. In the question, I want to know how many milligrams, I can't write, how many milligrams are in, let's say, 200 mLs of that solution. All right. Well, as soon as I see that problem, a bell's going to go off in my head. Ding, 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 I have a percent solution. I know I'm dealing with 0.45% sodium chloride. So I'm going to immediately come down here and write what that means. That means that there are 0.45 grams in every 100 mLs. That's half my problem. I know that right off the bat. So reading the rest of the question, this wants to know how many milligrams, so that's my X, are in 200 mLs of this solution. Well, I'm going to start with what I'm given. I know that I'm figuring out how much drug is in 200 mLs of solution. And again, I know I need to put that on the bottom. So looking at the top, I would write typically X milligrams. There's a problem, however. If I were to write X milligram, and I'll just write that for sake of seeing this, I cannot solve that because the unit on top does not match. So what we are going to have to do is turn this concentration into the equivalent milligram form when I'm given 0.45 grams. So to do that, you use the same methodology we used in our Introduction to Measurement Conversions module. So in essence, I need to convert this into the equivalent milligram. So I'm going to come down here and do a separate problem and say conversion. I need to know 0.45 grams is how many milligrams. Okay, I'm going to draw a line there so we don't get this all screwed up. So 0.45 grams is how many milligrams? Well, using what we did in the past, we got the kilogram to gram to milligram to microgram. I'm going from gram to milligram, which means I need to go right 3 spaces. 1, 2, we're going to add a 0, and that becomes 450 milligrams. So 0.45 grams is equivalent or the same as 450 milligrams. So I can actually write 450 milligrams here instead of 0.45 grams. Now I can solve that problem. So we do the cross multiplication, and we're going to divide by our remaining value. We talked about that. And what you are going to find is that the X milligram answer to this is going to be 900 milligrams, meaning that there are 900 milligrams in 200 mLs of that solution. So if I were to take that product, our half normal saline, 0.45%, I know that if I were to pour out 200 mLs of that product, I would have 900 milligrams of drug. So once again, this is just like our previous problems in that I identify the percent and I write out what that percent means as a fractional concentration. The only difference in this problem is that I was solving how many milligrams are in that product instead of grams. And when you are doing percent solutions, there are no ways around it. It is always that number of grams per 100 ml. So that's why I started there. It is not 0.45 milligrams. That is not the pharmaceutical standard. The pharmaceutical standard is that when you are given a percent, it is that number of grams per 100 ml. All right, now let's do one more problem together. I'm going to erase that. Let's do one more problem together. So let's say you are using a 50% isopropyl alcohol to clean. Okay. In the problem, I want to know how many mLs of isopropyl alcohol which is the active ingredient in this problem, and that matters in a second. How many mLs of isopropyl alcohol are in 0.2 liters of this solution? Okay, so looking at this particular problem, I would first see the 50% and know I need to convert that into the equivalent either weight to volume or volume to volume. So I'm going to write IA 50%, meaning isopropyl alcohol 50%. Now in all of our previous problems, we did gram to 100 ml. And that's because in the question, it said how many grams or how many milligrams. So we knew we were working with a weight. Now in this particular question, you will see that it states how many mLs of the drug, in this case active ingredient, are in how many 0.2 liters of this solution. So we are dealing with a volume in a volume. As soon as I see that, I'm going to state that 50% means there are 50 mLs of isopropyl alcohol in every 100 mLs of total solution. Okay? So the 50% in this case is a volume to volume. And again, I know that because I'm solving for a volume in a volume. Okay? So I got 50 mLs of isopropyl alcohol. How much of that is in 100 mLs of total solution? So looking at the other half of this equation, I need to see what I have and what I'm given. So what I'm given and what I need. Let me rephrase it that way. So I'm instantly going to see how many mLs of IA, or active ingredient, are in. Okay, so this is drug per volume, right? We've talked about that in our previous questions. So this is asking how many mLs of isopropyl alcohol are in 0.2 liters of this solution. Now hopefully you already see that just like our previous problem, we cannot immediately solve this. There's a conversion that has to occur. You cannot compare ml to liter. So you guessed it, I'm going to convert the 0.2 liters to the equivalent ml. So I'm going to come over here, do a supplementary conversion problem. Let's just draw some lines around it to separate it. So in this, I need to know 0.2 liters is how many mLs? Well, just like our previous problem, we know liters is here, milliliters is there. We are going right, and we're going to go right 3 spaces. So 0.2 liters is 200 mLs. I'm going to cross that off, and I'm going to write 200 mLs in place of 0.2 liters. I now can solve this problem. I'm going to circle that so it sticks out a little bit. Start at the value of the x, multiply across, divide that way, and you will find your answer. So our x mLs of isopropyl alcohol is going to be 100 mLs. And looking at the math, if there's 50 and 100, there's 100 and 200 because it's exactly half, right? So half of my volume is drug, and in this case, that's 100 mLs. So just like our previous problems, the math is the exact same. As soon as we see 50%, that means there's 50 something of drug in every 100 mLs of volume. So looking at this product, if there's 50% isopropyl alcohol, there are 50 mLs of isopropyl alcohol in every 100 mLs of total solution. Again, we're talking about a percent. We then compare that to the fact that we need to know how much drug would be in 200 mLs of that product. You then solve for X. So that is a very quick introduction to the concept of percent solutions. Once you've practiced with it a few times, it's not that complicated. It's very much like dealing with traditional dosage calculations. The only trick in these problems is to identify what the percent is telling me. And the key to remembering that is that a percent is something out of 100. So if we're dealing with a weight to volume product, that means that there are 50 grams in every 100 mLs. And if we're dealing with a volume to volume, it's a number out of 100. That means that there are 50 mLs out of every 100 mLs. So once again, that's our brief introduction to the concept of percent solutions. I would highly encourage that you practice. There are a lot of links available in Blackboard and around the internet to give you some examples to fill out more percent solution problems. And when you feel prepared, please try the percent solutions knowledge check. For this particular knowledge check, I'm going to give you 3 attempts to make sure that you get this right and do it to the best of your ability. If you have any questions as you complete the knowledge check, please contact me and I'd be happy to give you some more problems. So that's about it for today. Thank you for spending time learning percent solutions with me. Have a great one.